Welcome to another episode of the Distributed Data Show, brought to you by DataStax Academy, where we bring you the latest news and interview technical experts to help you succeed at building large-scale distributed systems.
Hey, welcome to another episode of the Distributed Data Show. I'm Cedric Lunven, your host, and today I have the pleasure to be with one of the guest star long-term contributor of Apache Cassandra, Sylvain Lebresne. And we will discuss about pretty exciting stuff introduced in DSC6, which is called NodeSync. But before we dig into too much spicy details, please, could you please introduce yourself?
Sure. Hello, I'm Sylvain Lebresne, and I'm a long-time member of DataStax core DB team. And I'm also, as you said, a long-time contributor to the Apache Cassandra project. We're talking 0-5 numbers, and so I'm a committer and a PMC member on the project.
Oh, that's a long of time, indeed. At DataStax, we used to say that DSC6 provide twice the performance with 0 of the complexity. Now, I think we already spoke about performance quite few times now, especially with the TPC episode. And today it will be more about simplicity and removing complexity. So Sylvain, could you remind us what is the anti-entropy Cassandra mechanism?
Yeah, so Cassandra and so DSC, which is based on Cassandra, are a distributed database with replication. That replication is often done asynchronously. What that means is that node can get out of sync, can get inconsistent, so you need mechanism to fix those inconsistencies between nodes when they appear. There's, by the way, a special case of inconsistency, which is data loss, where some node lose data and so is inconsistent with its peers. So for that, Cassandra has a couple of mechanisms. The two first one are like ints and re-repair, both of which helps with fixing inconsistency when they appear, but they are optimization. They are not guaranteed to always kick in, and so there's cases where they just don't work, and especially for data loss. Typically, they just cannot fix that. Actually, re-repair can, but ints cannot.
Okay.
Anyway, so the whole point is that we need a mechanism for kind of force finding those inconsistencies and fixing them. That's what anti-entropy is doing.
Okay. Basically, how does it work?
Yeah. So the way it works in Cassandra is we use what is called Merkle tree. That is the one of the node will ask for the Merkle tree of the replica. So basically, we're taking a range, we're splitting it into smaller ranges, and we hash the content of those ranges, and we send all those hashes back. The coordinator compare the hash, and if they have differ, it's able to say like this range is not consistent between the two replica. So then it will stream the data, between the replica A and B.
Okay. I think this anti-repair mechanism has been introduced quite a lot of time. Now it works quite well. Is there some known limitation about this mechanism?
Sure. So there's really kind of two buckets of problem with the entropy repair as it exists. The first one is performance impact on performance kind of thing. The first one is that repair tend to overstream a lot of data. So as we say, we have the hash of those ranges. So when we detect an inconsistency, all we know is that for some range that can be fairly large, there is something that differs. But that means we may stream a couple of megabytes of data just because there's just one small, very tiny inconsistency that's in. And there's also a reason why we overstream too much. The other ones, like it tends to be pretty bursty. Historically, it's not very well throttled for your workload. The second bucket of problem is just the way it's managed. You do require quite a bit of expertise, and it's pretty complex to manage repairing a cluster. One of the things that goes into that is so people using Cassandra know that if you don't repair often enough, there's a risk of resurrecting data, and that has to do with the way deletion is handled in Cassandra, the tombstones. So you basically need to make sure tombstone make it to every node. So you need to make sure they're replicated before what we call GC grace. And so that means you need to make sure repair is run within those kind of windows, otherwise you may have resurrecting data, and it can be challenging to make sure that this happens operationally, and if there's a problem, where the problem was, or can you restart the process. There actually is external processes that do that. There is one in OpsCenter, for example, the repair service. But the experience shows that it's usually a little bit fragile, and it doesn't work that well because there's stuff you can do better if you do them server-side. Those are external tools that do it kind of client-side. And so, yeah.
Okay, so I can see it as a kind of trade-off. If you don't it too often, you will build this huge Merkle tree and make a lot of streaming. And of course, you can lose some data, but you cannot also make it too often because it's a bit complex to handle. So I think this is where NodeSync came into play, right?
Yes.
So can you basically explain us what is NodeSync and what changed before?
Sure. So NodeSync is really a replacement of that anti-entropy repair, which basically aim to solve those two problems that I mentioned. So it's also split ranges into smaller ranges, so it repairs small ranges. But the ranges it repairs are smaller in general, and it's also does it more incrementally in a way that doesn't have this problem of a streaming. And more importantly, it's a pretty self-managed system. So it's distributed. Every node is repairing its own data.
Okay.
And so there's fault tolerance that is basically the same as Cassandra. You have the same kind of fault tolerance that you would have for anything else. And it's pretty end-off. So it's running all the time, and it's stored automatically. And the idea is that you set it on, and you don't really have to watch it, and it should make sure your data is up to date as fast as it can, and you ask it to go.
It sounds like a bit of magic, it's always running, so always doing what you need. But do you have to enable it or make it focusing on some tables against another, for instance?
Sure. So the way it works is that you decide which table have NodeSync enabled on which table it runs. So for that, it's a table property. So if you have a table and you say, I want to try NodeSync on my table, I just do an outer table on, with NodeSync equal true, basically.
Okay.
From that point on, NodeSync will start repairing it, and you can check the metrics and see if it works. OpsCenter has nice visualization to see where it's at and when parts are repaired. And I should mention as well that so if you want to enable on many table, we also ship with some kind of command line tool. There's this NodeSync tool that allows to enable it on multiple table. So you can do things like NodeSync enable on star, and all your table will get enabled. It's just a UI over the alpha table, but it just a little bit simpler. And you can do that in OpsCenter as well. Of course, you can get your table and you have a switch that you can manually toggle for just getting NodeSync.
Okay, it sounds so simple. I really like the idea to enable that stuff through CQL. I think it's a very nice way to help users to get the grips of NodeSync here. But some tables are bigger than others. In some there's a lot of tombstones, and some are only write-only. So I think we should be able to prioritize the NodeSync on sub-tables against another. Is this something we can do?
Yes. So the one thing you can configure on NodeSync is something like the deadline target, and it's very much target more than a deadline. And that's really saying, so getting back to this Tombstone resurrection and GC Grace, there was this notion that you have to repair every 2 weeks. You make sure that everything is repaired every 2 weeks, so a window of 2 weeks. And that's configured that value. So that value actually, so you don't have to configure it because it defaults to GC Grace, but you can actually change it and make it more aggressive, so independent of GC Grace. And NodeSync will prioritize table based on that value. So if basically if every table have the same deadline target, they will get the same priority. You will repair them fairly over time. But if one of your table has half of that deadline, it will be more aggressive. It will basically try to synchronize it twice as fast.
Whoa.
Pretty much.
Nice, nice. Okay, so NodeSync is pretty new features now. What kind of tests did you make to make it rock solid?
Yeah, we just run into our internal testing and you know, traditional multiple DC nodes and introduce fake loss of data basically, or forcing losing data and make sure it repair that. We also make tests around. So the good thing is that nothing will fix any inconsistency. So you can use it if you increase the replication factor, for instance, and you can just wait for it and make sure it does replicate the data in the new data center, or data loss or things like that. So you know, pretty standard testing you would imagine for that kind of feature.
Yeah, yeah, something like test to the limit. If something goes wrong, don't we lose anything? Stuff like kind of test as well.
Yeah, making sure we don't lose anything. That's what we expect is repair, and we check. We basically use the old repair as well that you can use to make sure that when NodeSync has run, nothing else is. So it's a double check of it's done its work as it would be, as good as repair would be, which is pretty well tested at least at this point.
Yeah, nice. Well, I think there's quite a lot of information to get. You should go and try it. Very easy to do it. It's all there. Just have to enable it. So welcome to be with us with another episode of the Data Show. And thank you, Sylvain, to be with us today. And let's have the pleasure to meet you again.
Thank you.
Thank you for joining us again for the Distributed Data Show. We love your feedback, so go to the Distributed Data Show page on DataStax Academy and tell us what you think. You can also find us on the DataStax Academy YouTube channel, or find our podcast on iTunes, Google Play, or wherever you get great podcasts. While you're there, make sure and subscribe so you don't miss a single episode.